Good day, Ron Gordon here. I work for Mainline Information Systems and I work in power systems. And I'd like to explain to you one of the latest technology changes that is now being exploited in the Power 9 arena. And it all has to do with I/O and not disks or that type of stuff. It's how is an I/O done and how is Power 9 going to improve the I/O performance to a level you're not used to. But to start with, we have to look at the general I/O process. And I put power systems, but it's the same general I/O process as an x86 or Z or any other architecture where you normally have a process running in an application. And every now and then, that process makes a request for an I/O. Could be an open, a get, a write, whatever. That call is actually a systems call to the operating system. Here I've designated AIX. Now AIX does not know how to do an I/O, but it does have these things called device drivers, which are an integral part of them. Now a device driver is associated with a particular device, be it a disk, a NIC card, or whatever. In this particular case, let's say the application is requesting a piece of data from a disk. AIX calls the appropriate device driver, which then goes to the power hypervisor, and all systems have a hypervisor. The hypervisor says, oh, this is an I/O, and it passes it to the chip, an x86 chip or a power chip, which has an interrupt handler in it, because there may be multiple I/Os outstanding. So the interrupt handler is posted as the I/O request is given to the appropriate device, the HBA. The data is read physically by this. This is doing nothing while this is going on. The data is then completed to the adapter, which has to put it into memory before the application is told, here's your data, continue. So the way it does that is the interrupt handler goes back to the hypervisor and says, this interrupt was satisfied. And the hypervisor says to the device driver, we're done, and it passes back the error codes if there are any, or everything is fine, which tells the operating system, tell that application, the data is done, and this is the address that we put it at, and please continue from the ECB block. And that's what it does. Now, you might have multiple I/Os going on, but they're all going through this environment. This is rather simplistic and the way it used to be. What's complicated factors is that most operating environments today have virtual machines or partitions. So I've taken this same diagram and modified it to what the Power 9 I/O technology has. That's called XIVE or XIVE. It really stands for External Interrupt Virtualization Engine. That's just useless information. So in this case, rather than have one partition, I've put in 3 or 4 or 5. So here's same diagram, but I've got a second partition, and just for simplicity, partition 1 requests an I/O. Partition 2 requests an I/O. Now these are completely different. If the first one completes, the hypervisor has to scan each AIX device driver to say, is this for you? Is this for you? Is this for you? Until it finds the one that it's for, because those are logged, the interrupt address. What they've done with this technology is they've put in the hypervisor a routing table for each LPAR. So for every LPAR you instantiate, you get a routing table. So when this requests an I/O, that I/O request is logged in the routing table, hardware. The hardware then knows, oh, that was from LPAR 1, and it's running on this virtual processor, because it has to know where the cache data is. And then it continues. So the Power 9 interrupt chip handles the I/O, the data comes back, goes to the hypervisor, and rather than querying each partition, is this for you, is this for you, is this for you, it looks in this table and it is given the address of where the data is, and it goes directly to the partition and says you are released. Now, when we consider that 80% of processing is normally in this aspect of the hardware, of the environment, 20% is done in this overhead area. Since this technology addresses the lower 20%, it probably reduces 75% of the overhead of this querying. So your performance is improved. This is totally transparent to any programming or application environment. But it is implemented only in the Power 9 chip. The latest AIX 7.2 TL4 has finally enabled it. This came out in 2017, and they've been testing it, and they just released it recently, within the past couple of months. You also have to be at 940 microcode level, and you have to be running at PowerVM 3.3.1. Why do you need the microcode? You need the table. Why do you need PowerVM? Because you need the VISO to keep it going. It's AIX only at this time. So you all that are running the AIX environment on Power 9, once you upgrade to these, you have it. There is nothing you have to do, and you should be expecting, depending on the granularity, 10 to 15% performance in I/O. So look forward to it.